Integration by parts. So substitution can be thought of the inverse of chain rule, and integration by parts can be thought of as the inverse of product rule. The formula is the integral of u dv is equal to uv minus the integral of v du. So the derivation is as follows. If u and v are functions of x with continuous derivatives, the derivative of the product u times v is equal to du dx times v plus u times dv dx. If I multiply both sides by dx, I get the differential of uv is equal to v du plus u dv. So now if I integrate both sides, the integral of the derivative of uv is just u times v is equal to the integral of v du plus the integral of u dv. If I subtract the integral of v du, uv minus the integral of v du is equal to the integral of u dv. So the integral of u dv is what we don't know. I turn it into some product u times v, and I'm able to compute the integral of v du. So for example, evaluate the following integrals. The integral of natural log of 5x dx. So u is equal to the natural log of 5x dv is dx. So the differential du is 1 over 5x times 5 dx. 1 over the inside times derivative of the inside. So du is equal to dx over x. If I integrate both sides with dv equals dx, I have v is equal to x. So the integral of natural log of 5x dx is equal to u times v. So x natural log of 5x minus the integral of v du. So x times dx over x, or 1 over x dx. So this turns into x natural log of 5x minus the integral of dx, which is just x. So x natural log 5x minus x. There's no more integral sign, so add some constant of integration. Evaluate the integral of x times secant of x tangent of x dx. So you pick a u that's something easily differentiable, and you pick a dv that's something that you can integrate easily. So u is equal to x, and dv is secant of x, tangent of x dx. So du equals dx, which means v equals secant of x. So this integral is u times v, so x secant x minus the integral of v du. So secant of x dx. So I get x secant of x minus the integral of secant of x is natural log absolute value of secant of x plus tangent of x plus c. The integral of 4 arc cosine x dx. So I'm going to let u equal arc cosine of x and dv equals dx. So du is negative 1 over the square root of 1 minus x squared, and v is equal to x. So if I factor out of 4 from the integral, u times v is x arc cosine of x minus the integral of v du. So negative x divided by the square root of 1 minus x squared dx. So 4 times x arc cosine of x plus the integral of x over square root of 1 minus x squared dx. Now that integral is a u substitution. U equals 1 minus x squared. So du is negative 2x dx. So du over negative 2 is x dx. So this integral turns into 4 times x arc cosine of x minus 1/2 the integral of du over square root of u, which is 4 times x arc cosine of x minus 1/2 times the integral of u to the negative 1/2 du. I'll use power rule on u to the negative 1/2. So 4 times x arc cosine of x minus 1/2, increase the power by 1, divide by the new power, and add a plus c since there's no more integral. If I replace u with the square root of 1 minus x squared, and if I distribute the 4x arc cosine of x minus 4 times the square root of 1 minus x squared plus c. Okay, with integration by parts, if there's a polynomial times a sine or a cosine, you can do integration by parts multiple times. An easier way is the tabular method. The tabular method is used if you can take a derivative of a function down to 0, and then you can integrate the other function. So I'll make a column for x to the 4th, and then a column for cosine of 2x. I'm going to differentiate the column on the left down to 0. So first derivative is 4x cubed. The derivative is 12x squared. Then 24x. Then 24, then 0. If I integrate the column on the right, one half sine of 2x, negative 1/4 cosine 2x, negative 1/8 sine 2x, 1/16 cosine 2x, and then 1/32 sine 2x. Then you multiply diagonally. And you alternate your signs. So plus, first sign's a plus, and then it keeps alternating. So this integral is going to be this times this is the first term. So this integral is equal to 1/2 x to the 4th sine 2x, and then this term times this term minus a negative will turn into positive. So plus x cubed cosine 2x. Then the next product, which turns into minus 3/2 x squared sine 2x. I'll continue below. Minus 3/2 x cosine 2x. And then last term, plus 3/4, 24/32 is 3/4, sine of 2x. And then plus some constant of integration. The integral of e to the 4x cosine 2x dx. Okay, this is a solve for the integral case. So I'm going to do integration by parts twice. You can let u equal the exponential or u equal the trig function. Either one works, just be consistent. If I let u equal cosine 2x, du is negative 2 sine 2x dx. And dv would be e to the 4x dx. If I integrate, v equals 1/4 e to the 4x. So u times v, 1/4 e to the 4x cosine 2x minus the integral of v du. So minus 1/4 times negative 2 minus a negative will turn into plus. I'll factor out the 1/2 e to the 4x sine 2x dx. I'm going to do integration by parts one more time. If I let u equal the trig function, and then dv is e to the 4x dx. So du is 2 cosine 2x dx, and v equals 1/4 e to the 4x. So this is equal to 1/4 e to the 4x cosine 2x plus 1/2 times u times v, so 1/4 e to the 4x sine 2x minus the integral of v du. So 1/4 times 2 is 1/2. I'll factor out the 1/2 e to the 4x times cosine 2x dx. I'll take this 1/2 and distribute this 1/2. So 1/4 e to the 4x cosine 2x plus 1/8 e to the 4x sine 2x minus 1/4 times the integral of e to the 4x cosine 2x dx. Now, by doing integration by parts twice, this part matches the original integral. So I'm going to call the original integral I. And then I'm going to replace this integral with I also. And since I did integration by parts, this whole integral is equal to I. So my integral is equal to 1/4 e to the 4x cosine 2x plus 1/8 e to the 4x sine 2x minus 1/4 I. And I is the original integral, which I want to solve for. So I'm going to add 1/4 I to both sides. So 1 plus 1 over 4 is 5 over 4i. So 5/4 I is equal to 1/4 e to the 4x cosine 2x plus 1/8 e to the 4x sine 2x. To get I by itself, I'm going to multiply both sides by the reciprocal. So I is equal to 4/5 times 1 over 4 e to the 4x cosine 2x plus 1/8 e to the 4x sine 2x. Since I solve for I, I'll add some constant of integration. So if I distribute the 4/5, the integral is 1/5 e to the 4x cosine 2x, and then 4/5 times 1/8 is 1/10 plus 1/10 e to the 4x sine 2x plus c. So that's the solve for the integral case. Integrate cosine of root x dx. So first I'm going to do a substitution. Let u equal root x. So u squared is x. So 2u du is equal to dx. So if I replace everything in terms of u's, the integral will turn into cosine of u, and dx is 2u du. I can factor out at the 2 times the integral of u cosine u du. So now this is integration by parts or tabular integration. I can take a derivative of u down to 0, and then I can integrate cosine of u. The integral of cosine is sine u. The integral of sine is negative cosine u. Then multiply on an angle and alternate the signs. So this integral is equal to 2 times u sine u minus a negative, so plus cosine u, and then plus c. If I distribute the 2 and replace u with square root of x, so 2 root x sine root x plus 2 cosine root x plus c.